In this problem, if you begin with 25.4 milliliters of 0.249 molar hydrochloric acid solution and mix it with 24.2 milliliters of 0.226 molar sodium hydroxide, what is the final pH when they are mixed together? Let me ask you a question, everybody. There's two possibilities for this. One is that sodium hydroxide is the limiting reactant, and the pH will be less than, so an HCl is excess, and we will get a pH less than 7. There's also the possibility that we end up with a pH over 7. And I can work both of them. I will tell you, just looking at this problem, I have more milliliters of my HCl, and I have a higher concentration of my HCl. That means I will have more moles of my HCl. And because it's 1 to 1 to 1 to 1 stoichiometry, that means that my pH for this problem, just looking at the numbers, pH will be less than 7, and HCl will be in excess. Sorry, so there we go.
So that means we're finding the pH of HCl.
For this problem, we will be finding the pH of HCl because that will be left over. We'll calculate the moles left over.
Right.
And then we'll put it into molarity and we'll go to pH. And why don't we do this one? And if you'd like to, just like the last problem that I did, I will then do one where the pH is greater than 7 if you'd like. Okay? But then, yeah, let's see. Because, again, this is an important concept. So that's why we're doing it again. And we did it on the recitation and the homework previously. So, all right. But so functionally, it's a lot like some of the previous problems we've worked on the homework this week. We have a volume and a molarity, so we can find moles of HCl. We have a volume and a molarity, so we can find moles of sodium hydroxide. And what's different about this one is because we have what's called 1 to 1 to 1 to 1 stoichiometry, we can just find the moles of reactants and evaluate our limiting reactant based on moles of reactants. I will say before I do this, that if you do this process that we did in the previous problem where you actually find moles and or grams of product, you'll still get the right answer. It'll just be an extra step or two. So, but again, your challenge is to make sure that you know how to get the right answer for this problem. Anyway, that was always the challenge, I guess. But okay, so we know we have our milliliters and our molarity. And actually, what I'd like to do is I'd like to ask if somebody could tell me the moles of HCl, and if somebody else could tell me the moles of sodium hydroxide they're going to get from working this problem. And then we'll move on from there.
Well, it'll just be, what is it? Hold on one second. For the moles of hydrochloric acid, it'll be 0.0254 liters, 0.0254 liters times the moles will be 0.249 moles of hydrochloric acid.
You got it.
And that'll be the moles of hydrochloric acid, right?
You got it. So what do you got for me, Mike? And somebody else be working on the moles of sodium hydroxide, please.
0.0063.
One more digit, please. Or is it just...
Well, you're right, 0.00632 moles of hydrochloric acid.
Thank you. Does anybody else have moles of sodium hydroxide? And you can post it in the chat or you can let me know.
Yeah, it's 0.00546. Yep, that's what I got too.
0.00546. Perfect.
For
Thank
7.
you.
Approximately for 7.
So is this last digit round to a 7 or is it a 6?
Yeah, to 7.
Thank you. Okay. And so thank you. And so I missed the names there, but thank you very much. So like I said before, we can see that we have more moles of HCl, and that means that it will be in excess. And my sodium hydroxide will be my limiting reactant. There we go. Okay, and then the next step will be to recognize, because it's one-to-one stoichiometry, the moles of sodium hydroxide are also equal to the moles of HCl that react away. So equals 0.00547 moles HCl reacted away. And so when we subtract these two numbers, we will get the moles of HCl left over. Okay, any questions about that? If not, zero point zero 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 85. Moles of HCl left over. So, and that's, again, we know that the pH is going to be less than 7 whenever there's acid left over. Our next step is to take those moles, divide them by the total volume, so that we can get our concentration of hydrochloric acid. And our total volume, well, so we're going to get 49.6 milliliters. Which is, move the decimal point over 3 places, 0.049 liters. And now this problem looks similar to some of the ones we did before. So now we are going to find our concentration of our HCl. It will be the concentration of our H+, and we can find pH. So I've still got my 0.00085 in there, divided by my 0.0496, 0.0171 molarity HCl. All right, yeah. That looks right. And one test that things are going okay at this point, since we've worked a number of these problems, is that our molarity of our HCl must decrease because we've reacted some of it away. So if you get to this point and you get a number larger than what you started with, please recheck your math. Is there a question? No? Okay. Okay, and then we know that this is equal to the concentration of H+, and we can do our pH straight away.
Yeah, Prof, that is 0.0172 approximately.
0.2, let's take a look. So I'm just using this 0. And again, if you get 0.00172, because there was numbers up here that were slightly different, you didn't round them, so
Okay.
you'll be fine.
Okay.
Yeah, so small rounding differences are always okay.
Doesn't matter. Okay.
Yeah.
Thank you.
And I can say another word about that, which is inside the blackboard, I set the tolerance for all the answers to be plus or minus 2%, which allows for any rounding to be taken care of, or not rounding if you use the exact numbers for each of the problems. So yeah, no,
Thank you.
Thank you. Go ahead. Yeah, so if you get a slightly different number, it'll be fine.
Okay.
0.0171 log, I get 1.77 as my pH.
Can we do this? It's simple when I'm doing it, but the more practice, the better I get at it. So the sodium hydroxide is the limiting reactant instead of hydrochloric acid.
Definitely. Yeah, no, that's exactly. So, and I think, I don't know about you, but for me,
Sorry, reverse. Sodium hydroxide is the excess, and
yeah,
yeah.
yeah, no, for me, seeing them side by side really helps. So,
I
and
know we just did it, but it's just, I don't know. It's a lot to take in sometimes. So
totally. So, how about this? I'm going to keep this the same for my HCl, and I'm going to change this to 34 milliliters,
okay.
and then we'll work that one, and I'll just do it on the back. So 25.4 milliliters. Of 0.249 molar HCl and 34.2 milliliters of 0.226 molar sodium hydroxide. And let's see, so 25.2, okay. And the question is, as always, what is the pH? Okay. And what we'll do is we know that the moles of HCl are the same, so 0.00632. And Mike or anybody, do you have the moles of sodium hydroxide?
Is it
0.00773.
Is that what everybody gets?
Yes, I got the same thing.
Excellent. And we're going to go ahead and put it on top. And that's only because I know that we've set it up so that it will be larger so that I can do my subtraction. And I'll make the note that this is in excess for my sodium hydroxide. And then my HCl is my limiting reactant. And further, that the moles of HCl are equal to the moles of sodium hydroxide that react away. So that I can very clearly see that this is the subtraction I need to do because I have my starting moles, I have my moles reacted away, and I can use it to find my leftover moles.
0.00141.
Thank you. I think that was in Kira. Thank you. Okay. Great. So now, again, we know that our pH, let's see, note to self, pH has to be greater than 7 for this one because we know that we have leftover sodium hydroxide. We find the concentration of that sodium hydroxide with our leftover moles. Divide it by our total solution, which should now be 59.6 milliliters, and put into liters 0.0596 liters. Zero point 0.0237 again. So these are my numbers, but if you get something slightly different, totally fine. As my molarity of sodium hydroxide. And my POH is going to be my negative, well, let's see. So let me not skip any steps. So this is my molarity of sodium hydroxide. Sodium hydroxide is a strong base, which means it's also my concentration of my hydroxide ion. And I can find my POH then, because POH is the minus log of the concentration of hydroxide ion. Plug that in. 0.0237 log. I get minus 1. Question? Or answer. I get 1.63 again. Depending upon exactly what numbers you use, you'll get something close to that, if not the same. And here's the key step. So again, you know your pH has to be greater than 7 for this. You know, and so you know you're not done because you've got a number less than 7. And that's just a memory jog to say the pH is going to be 14 minus POH. Or 14 minus 1.63.
12.37.
12.37. Thank you. I think that was Vanessa.
Hi, Professor.
Hi. Oh, maybe that, yeah. So sorry, I had a couple people that I thought were talking there. So thank you for the 12.37.
Professor?
Vanessa, go ahead.
Yeah, I was trying to solve this problem, and the moles of HCl and the moles of sodium hydroxide was the same. Can we do it a little bit? I'm so sorry I had to meet you in your office hours to work on this. But
No worries. So let's cover that one as well.
yeah, so it was 50.0 milliliters of 0.200 moles of hydrochloric acid and 40.0 milliliters of 0.250 moles of sodium hydroxide. And when I did the math, it was the same, like zero. So I didn't know which one was the limited reactant and which one was the excess reactant.
Oop. NaOH. So Vanessa, you got 0.0100 moles of sodium hydroxide and the same number of moles of HCl is what you're saying,
Yes.
right? Okay.
It's the same.
Yes. And so interesting, such a good question. So which one is your limiting reactant then?
It's all the same.
They're both the limiting reactant. Yes. And actually, we may run into this on today's recitation as well, so in a slightly different context. So since they're both the limiting reactant, that means that there's no sodium hydroxide left over. And there's no hydrochloric acid left over.
Okay.
And so then the question might become, well, what is left over? And so then the only thing you have, so there's only products. And now our answer that we're going to get to, we can get to in a couple of different ways, but let's talk about this. Let's try this way first. So if there's no base, so the pH cannot be above 7. There's no acid, so the pH cannot be below 7. And so if there's no acid or base, pH must be 7. And we technically say 7.00 because all pHs have 2 decimal places.
Oh, thank you so much, Professor.
Yeah. And just another reference point for this one is if we go back to our original equation, so we just said there's no HCl, there's no sodium hydroxide left over, so the only things we have are water and sodium chloride. And if the question, and we won't ask this, but if the question was, what is the pH of a sodium chloride in water solution? Again, we would just expect it to be 7 because there's no acid and no base there. Anyway, that's a slightly different approach, but it works both ways. So we've reacted away anything that changes pH, and we're left with only things that don't change the pH. So again, it's pH 7. Anyway, good question. Any questions about that?
That was a recitation from last week as well, but it was like you posed it in a question. Like I was confused. I mean, I knew the answer was 7. The pH was 7, but I didn't really know what to do mathematically. I thought there was something I had to do. I just wrote out it's just 7.
Yes. So there was nothing to do calculations wise. I mean, the only thing you could do is if you got that the moles were equal, this might be your thought process, but it's all that there's no other calculations you can do, which is, I know, pretty different than all, having a full page of calculations just to find the pH. So think of this as a third type of calculation, which you don't see very often, but it's if both of them are limiting reactants, then the only things left are products. So I know, just when we thought we were feeling good, huh? But I will say this on your exam, the next exam. So this will not be a possibility, right? I'll program in only things where the acid and the base are different than each other. And then we'll keep thinking about this as we go, and we'll feel better about it hopefully over time. But that's the idea, is that, so if they're both the same, then there's no reactants and there's only products. And my goal is that if we're going to do a case like this, that we will practice it enough until we feel comfortable, and then we can put it on the test. But not for now. Anyway, any other questions about, so this is sort of acid-base limiting reactant problems. We've done one in which the limiting reactant is the sodium hydroxide. We've done one in which the limiting reactant is the HCl. And now, this is awesome, we've done one in which both of them are limiting reactants. That is all the cases that are possible. Okay.